In section 4.5, we're going to talk about solving quadratic equations. So whenever a graph of a function f of x intersects the x-axis, that would be where the function f of x is equal to 0. A value of x where f of x is equal to 0 is called the zero of a function. So to find the zeros of a quadratic function, f of x equals ax squared plus bx plus c, you just set your equation to 0 and then you solve from there. And there's going to be a couple different ways we can solve. So in that last section, we learned how to factor. That's one way we can solve. We're also going to learn how to do that in our graphing calculator in this video. And finally, we're going to figure out how to do this using the quadratic formula by the end of the unit. Another important note here in solving these types of quadratic equations is the zero product property. The zero product property states that if a times b equals 0, then either a is equal to 0 or b is equal to 0. And basically what that's saying is that if we have an equation and it has a bunch of different terms in it that's being multiplied, if any one of those terms is 0, as we know, 0 times anything will make everything 0. So that's kind of what we're getting at here. So in our first example, I want to find the solutions of x squared minus 5x plus 6 equal to 0. Now using what we learned before, let's factor this. So as my leading coefficient's 1, I could really just think, okay, what are two numbers that multiply to give me positive 6, add up to give me negative 5, which I would have x minus 3 and x minus 2. And from here, what I'm going to do is split off this into two different equations. So I'm going to set x minus 3 equal to 0 and x minus 2 equal to 0. From there, I'll solve for x, and then I'll solve for x again. So x could be equal to 3 and x could be equal to 2. And one way that I can check to see of like, okay, how do I get two different solutions here is I could double check this by plugging it back in. So first let's plug in 3 wherever I see an x and we'll see what works out. 3 minus 3 will leave me with 0 times 1 equals 0. So by the zero product property, one of those terms is equal to 0. So now I have 0 equals 0 and that checks out. If I plugged in 2, now I see I had 2 minus 2 equals 0. Again, I have 0 equals 0 and everything checks out as well. Another way I could do this is by graphing. And this is especially helpful in any real world type problem that you deal with where it's not necessarily going to be as easy to factor, especially if your zeros aren't these nice whole numbers. Especially, if you have like a decimal, something weird like that. Knowing how to do this by graphing is going to make this a lot easier. So here I want to find the solutions of the equation 2x squared plus 7x equals 15. And if I want to solve this in the calculator, or even if I want to factor it, I want to make sure that everything's to one side. So what I'm going to do first here is bring that 15 over, and now I'm left with 2x squared plus 7x minus 15 equals 0. And again, just keep in mind, I could solve this by factoring as well, but I'm going to do this in the graph just so we can see two different ways of doing it. From here, I'm good to go to graph it, so I'm going to take out my graphing calculator. I'm going to go into y equals to graph it. I'm going to type in that equation, so that part that has the 2x squared plus 7x minus 15, I'm not going to include the equals 0. I'm going to just see where it crosses the x-axis. That would be where it equals 0. From there, I hit graph, and now my graph appears here. Now you can see that if you're doing Zoom Standard, that this kind of goes, or I can't really see my minimum value. It kind of goes off the graph a little bit, but what I'm trying to look at here is where I'm crossing the x-axis. I could see both points where it does, so I don't really need to adjust like a zooming in or zooming out or anything. From here, again, I'm looking for a specific point on the graph, so I'm going to press second trace again, and now I'm into that menu similar to what we did a couple sections ago. And now I'm going to go to option 2, which says 0. I'll press enter. And now again, it's going to ask me for a left bound and right bound. So you'll have to do this twice to narrow in on both zeros. So for my left bound, starting with this leftmost x-intercept, I'm going to click over to the left, to the left of that x-intercept. I'll press enter. It's going to ask me for a right bound, so I'll click over to the right. It'll ask me to guess, press enter again. And in that bottom of the screen, I see that my x-intercept is at negative 5, 0. So one of my solutions here is x is negative 5. Now I want to do this process again to find my other x-intercept, so I'll hit second trace again, 0, enter, and then if I do that process again, I'll see that my other x-intercept is at positive 1.5. So my solutions to this algebraic equation is x equals -5 and x equals positive 1.5. And again, since we're solving for x here, you could double check this by plugging both of these values back into your equation and seeing that it works out. The last thing that we'll talk about in this video is the different types of solutions that we can get for any ax squared plus bx plus c equals 0 equation. So the example that we just saw, we saw a graph where I crossed through the x-axis at 2 different points. And that's an example of having 2 solutions, which is why I got 2 different x values as my answer. There's also situations where maybe just your vertex hits the x-axis. So in that case, I would only have 1 solution. And then finally, if I have a situation like this, where I have my parabola not crossing the x-axis at all, I would have no real solutions here. As of right now, I'll just say no solution. Later in this unit, we'll learn how I could have an imaginary solution. While I don't necessarily have a real solution, I could have a different solution in a different set of numbers.